Hi learners, this is your Shahid. Welcome to Soul of Physics YouTube channel. Please subscribe my channel and share to your friends and like my Soul of Physics YouTube channel. Today we are going to discuss the topic carrier concentration in intrinsic semiconductor. We know that what is semiconductor? The materials whose electrical conductivity is intermediate between conductor and insulators, those materials are called semiconductors. Semiconductors again classified into two types. One is intrinsic semiconductor, another one is extrinsic semiconductor. Pure form of semiconductors is known as intrinsic semiconductor. Impure form of semiconductor is known as extrinsic semiconductor. So we define intrinsic semiconductor in other words that the semiconductors in which charge carriers, that is electrons and holes, are generated by approaching the large temperatures. Those semiconductors also referred as pure form of semiconductor or intrinsic semiconductor. Now we are going to derive the expression for carrier concentration in intrinsic semiconductor. Carrier concentration means number of charge carriers present per unit volume of the intrinsic semiconductor is known as intrinsic carrier concentration. In intrinsic semiconductor, electrons are present and holes are present. Both are responsible to get the electrical conductivity in the case of intrinsic semiconductor. So when the n group of atoms are combined together, instead of isolated energy levels, a band of energy levels are formed. A band of energy levels which are completely filled, those band of energy levels are called valency band. Those band of energy levels are called valency band. A band of energy levels in which electrons are filled partially, those band of energy levels are called conduction band. Conduction band. Okay. A gap takes place between conduction band and valency band is known as energy gap. Is known as what? Energy gap. In the case of intrinsic semiconductor, holes are present in valency band, electrons are present in conduction band. So when we find out how many electrons are present in the conduction band per unit volume, so similarly we can get same number of holes present in valency band per unit volume, because number of electrons in the conduction band is equal to number of holes in the valency band in the case of intrinsic semiconductor. In the case of intrinsic semiconductor, number of electrons is equal to number of holes. And the Fermi energy level, it lies between conduction band and valency band. The Fermi energy level, it is represented by letter EF. It lies at the middle of the energy gap in the case of intrinsic semiconductor. In the case of intrinsic semiconductor, the Fermi energy level EF lies at the middle of the energy gap which is present in between conduction band and valency band. Okay, now first of all we have to find out how many electrons are present per unit volume in the semiconductor, in the intrinsic semiconductor. So as well as we can get number of holes present in the intrinsic semiconductor per unit volume. So from these values we can find out net carrier concentration present per unit volume in the case of intrinsic semiconductor. So remember the point, number of electrons is equal to number of holes in the case of intrinsic semiconductor. Let Dn be the number of electron. I consider Dn be the number of electrons present. Dn be the number of electrons present in between E and E plus dE energy level. In between E and E plus dE energy level in conduction band. See here, let Dn be the number of electrons present in between E and E plus dE energy level in conduction band. So Ec be the lower energy of the conduction band, E be the energy level in the conduction band, and here this is a E plus dE is the another energy level. In between the energy level E and E dE, Dn be the number of electrons present in between E and E plus dE, then Dn can I write as Dn is equal to Z of E dE into F of E. Here Z of E dE represents density of energy states. Density of energy states means number of energy levels per unit volume in the conduction band. Its value is Z of E dE. I can define as 4 pi by h cube 2 mass of the electron 2 me whole power of 3 by 2 E minus Ec whole power 1 by 2 dE. Okay, and next one is a F of E. F of E is a Fermi-Dirac distribution. F of E is a Fermi-Dirac distribution. So Fermi-Dirac distribution is a probability function. It represents what probability have the electron to occupy particular energy state E. To occupy particular energy state E, what probability have the electron, that probability defined by Fermi-Dirac distribution function. As per Fermi-Dirac statistics, F of E is equal to, I can write 1 by 1 plus E power E minus EF by kT. Here E minus EF is greater than kT. E minus EF is greater than kT. E is a energy level in the conduction band. EF is a Fermi energy level. It lies at the middle of the energy gap, which is lie between conduction band and valency band. So that's why E minus EF is a greater than thermal energy. Hence Fermi-Dirac distribution function can be write as E power minus of E minus EF by kT. Okay, now Dn is equal to number of electrons lie in between Ec and E, lie in between number of electrons lie in between E and Ec. dN is equal to Z of E dE F of E. See here, Z of E dE I define like this. So can I substitute here? 4 pi by h cube 2m whole power 3 by 2 E minus EC whole power 1 by 2 dE, and F of E, we get F of E is 1 by 1 plus e power E minus EF by kT. Based on this condition, the whole function transformed into e power of minus of E minus EF by kT. We can write e power minus of E minus EF by kT. Now you want to find out total number of electrons in the conduction band. Total number of electrons in the conduction band from the energy level EC to infinity energy level. So that's why I can integrate n is equal to integral dN is equal to 4 pi by h cube 2m whole power 3 by 2. These all are constant. So integral EC to infinity E minus EC whole power 1 by 2 e power minus of E minus EF by kT into dE. Yes. Now see here. Now n is equal to 4 pi by h cube 2m whole power 3 by 2 e power minus E by kT e power plus EF by kT e power plus EF by kT. Fermi energy level in the case of intrinsic semiconductor is a constant. So that's why I can write outside e power plus EF by kT integral EC to infinity E minus EC power 1 by 2 e power minus E by kT. Now the above equation is multiply with e power minus EC by kT e power plus EC by kT. Now the above equation multiply with minus EC by kT e power plus EC by kT, minus EC by kT and plus EC by kT. So as a consequence, the equation become as 4 pi by h cube 2m whole power 3 by 2 e power EF minus EC by kT. Here E minus EC by kT I multiplied. There plus EC by kT can multiply. Now equation become as EC to infinity E minus EC whole power 1 by 2 e power of minus of E minus EC by kT. Minus minus plus EC. Here e power plus EC by kT, here e power minus EC by kT, then the above equation we can get. Same equation. We can't alter the any equation. So that's why we multiply with e power minus EC by kT. We can multiply with e power plus EC by kT simultaneously. So as a consequence, the above equation is doesn't alter. So to solve the above equation, see here, now I consider x is equal to E minus EC by kT. Now I consider x is equal to E minus EC by kT. As a consequence, x kT is equal to E minus EC. Now dx kT is equal to we can write as a dE. EC is the lower energy of the conduction band. It is a constant. That's why 0. E is become as a dE. dx kT is equal to dE, x is equal to E minus EC by kT. dE place can I substitute dx kt, E minus EC by kt place can I substitute x. So now we can go for limits. If E is equal to EC, if E is equal to EC, E equal to EC, then x become as 0. X become as 0. Then E become as infinity. If E is equal to infinity, infinity minus something by kt, again infinity. So that is x is equal to infinity. Now hence n is equal to 4 pi by h cube 2m whole power 3 by 2 e power ef minus ec by kt integral limits can be transformed. If e equal to ec, x become as 0. Yes. Now if e is infinity, so integration with respect to dx limits also changed as a infinity. E minus ec whole power of 1 by 2 here. E x equal to E minus ec by kt. E minus ec is a x kt. E minus ec power 1 by 2 is a x power 1 by 2. kt power 1 by 2. Yes. Now e power minus ec by kt, and here also d is there. Here also d is there. Okay. Now x power 1 by 2, kt power 1 by 2, e power minus x, and d place can write as a kt dx. kt dx. Now the equation become as n is equal to 4 pi by h cube 2m whole power 3 by 2. kt power 1 by 2 into kt. That is also kt power 3 by 2. We can write this one 2m kt whole power 3 by 2. Now e power ef minus ec by kt integral 0 to infinity x power 1 by 2, x power 1 by 2, and x power 1 by 2 is there. Yes. Now here e power minus x kt over power, see here x power 1 by 2 can write as this one, x power of 1 by 2 e power minus x dx. Now this one can write as n is equal to 4 pi by h cube 2m kt whole power 3 by 2 e power ef minus ec by kt integral 0 to infinity can write as a x power 1 by 2, x power 1 by 2, like that. X power 1 by 2 can write like this, x power 3 by 2 minus 1 and e power minus x dx. See, in this equation integral 0 to infinity x power n minus 1 e power minus x dx is look like a gamma function. Integral 0 to infinity x power n minus 1 e power minus x dx is a gamma n function. So by comparing this one, see integral 0 to infinity x power 3 by 2 minus 1 e power minus x dx can write as a gamma 3 by 2. Yes. Now gamma 3 by 2 value is can write as a gamma 3 by 2 can write as a n gamma n. I means n plus 1 n gamma n. That's why I can write as a 1 by 2 gamma 1 by 2. 1 by 2 gamma 1 by 2. Gamma n plus 1 can write as a n gamma n. N gamma n. That is a gamma 3 by 2. It look like a gamma 1 by 2 plus 1. This look like a gamma n plus 1. Gamma n plus 1 means n gamma n. That is a 1 by 2 gamma 1 by 2. Gamma 1 by 2. 1 by 2 gamma 1 by 2 means 1 by 2 gamma 1 by 2 value is root pi. 1 by 2 gamma 1 by 2 value is a 1 by 2 root pi. See here integral 0 to infinity x power 3 by 2 minus 1 e power minus x dx is equal to gamma 3 by 2. Its value is a totally 1 by 2 root pi. 1 by 2 root pi. So can write this expression, if value is a root 2, 1 by 2 root 2 pi. So then final equation is become as, see here, n is equal to 4 pi by h cube 2m kt whole power 3 by 2 e power ef minus ec by kt. See, integral 0 to infinity x power 3 by 2 minus 1 e power minus x dx value become as 1 by 2 root pi. 1 by 2 root pi. 1 by 2 root pi. Then n is equal to these 2 and 4 cancel. 2 is there. Here pi is there. Here pi 1 by 2 is there. That is a pi power 3 by 2 and pi power 3 by 2. That word, the term will be included in this one. Hence it become as 2 pi m kt. Okay, h cube is there. That can be write as h square whole power 3 by 2. Then h square whole power of 3 by 2 square root cancel, again it becomes as h cube. Then e power ef minus ec by kt. So this is a number of electrons per unit volume in the conduction band. Already we know that number of electrons are present in the conduction band, number of holes are present in the valency band. So similarly, number of holes is equal to 2 pi m for mass of the charge carrier. Now charge carrier we taken as a whole, that is the mass of the whole, kt by h square whole power 3 by 2 e power lower energy. Here lower energy holes are present in valency band. Okay, that's why valency band upper energy level is a lower level than compared to Fermi energy level. That's why I write as EV minus EF by kT. So already we know that number of electrons is equal to number of holes. That is Ni is equal to Ne is equal to Nh. So similarly here Ni square is equal to NeNH. Ni square is equal to NeNH. Ni square means Ne into NH. Ni is Ne. Ni is NH. Ni square means Ne into NH. So Ni square is equal to, we can multiply these two or twice, 2 into 2, 4, 2 pi kt by h square, 2 pi kt h square whole cube, square and root cancel. But mass of the electron, mass of the holes are different. That's why Me, Mh 3 by 2, power 3 by 2, and E power minus EF plus EF is cancelled. E power EV minus EC is kT. E power EV minus EC by kT. Now Ni is equal to under root, Ni is under root 4 become as a 2, and there is a root value here 2 pi kt by h square whole power 3 by 2, and already 3 by 2 is there, a root is there, then become as a 3 by 4. Me Mh whole power 3 by 4 e power EV minus EC by power 1 by 2, that is a 2 kT. Yes. Now this one EV minus EC. Energy gap is a EC minus EV. Energy gap is a EC minus EV. When you get the negative sign, get the common of negative sign, that is become as a minus of EC minus EV. Minus of EC minus EV means minus of energy gap. Hence the final equation becomes Ni is equal to 2 pi kt by h square whole power 3 by 2, mass of the electron, mass of the hole, power 3 by 4, e power minus of Eg by 2 kT. So this is the expression for carrier concentration per unit volume in the intrinsic semiconductor. This expression tells us that when temperature increases, what happened? Temperature increases. What happened? So this value becomes rises. This value becomes rises means Ni value rises. So when temperature increases, carriers increases, conductivity also increases. So in intrinsic semiconductor, temperature increases, carriers increases, as a consequence conductivity also increases. So this is the expression for intrinsic carrier concentration in intrinsic semiconductor.